Hello world, it is time to share another beautiful video on the amazing ray tracing results that Intel's new AI brings. Before we go on, do not forget to like this video and subscribe to this channel to get premium content for free. Please note that some of the information in this video was obtained from 2-minute papers with Dr. Carole Jolnai-Feher. You can check out his channel too. With that said, let's get started. Intel says its new method is for interactive renderings that push the boundaries for graphics, path tracing, computing, simulation, and 3D design with a complete portfolio of leading hardware and software. With this, you can get the flexibility of open unified programming, combined with the unparalleled features and performance needed to create photorealistic renderings that scale end-to-end on laptops, workstations, HPC, and cloud. Intel hardware has development tools that will help artists and developers build new worlds for film, VFX animation, 3D design, and gaming. It will also help scientists and researchers to deepen their understanding of the world through scientific visualization. Intel's key hardware optimizations have incredible performance and efficiency of advanced ray tracing, allowing users to pair Intel with portability across endpoint devices, workstations, data center servers, and HPC nodes. Intel specifically designed their new method to meet workload, hence they make use of the API heterogeneous programming. This approach removes the barriers of proprietary programming models and enables more seamless, sustainable workflows with increased collective innovation. Intel says that it collaborated with industry consortiums, standards bodies, open source communities, and universities/research organizations to accelerate and achieve its new ray tracing technologies. Dr. Carole Jolnai-Feher explained Intel's new light transport simulations, and we will do our best to break it down for easier understanding. He showed how Intel's amazing new technique can detect and erase noise in simulations. Did you see that? To create a truly gorgeous photorealistic scene in computer graphics, it is necessary to reach out to a light transport simulation algorithm. After this, there still seems to be tons of noise in the simulation. The reason is that during simulation production, one has to shoot millions and millions of light rays into the scene to estimate how much light is bouncing around. And before enough rays are simulated, the inaccuracies in estimations or time calculated will show up as noise in the images. Although these noises might clear up over time, they may take a long time. Dr. Carole Jolnai-Feher showed how this was possible, and I'm sure you can see the reference simulation footage for the paper too. Can you spot the noise? As earlier said, the noise will eventually clear up, but it won't do so quickly. According to Dr. Carole Jolnai-Feher, a video like this might still require hours to days to compute. Dr. Carole Jolnai-Feher went further to show, as you can see from this video, the result of the previous paper that took 3 weeks to finish after running it on multiple computers at the same time. But with Intel's new AI, you don't have to wait that long to have a good result. Dr. Carole Jolnai-Feher confirmed that all he had to do was to just wait for about 10 milliseconds, and the result was very good. He even ran a noise filtering technique that is specifically tailored for light transport simulations. Look at what he got. It's probably not much difference at first, but the difference is very noticeable. As cross-checking with the previous method, Intel's AI result is way better. Dr. Carole Jolnai-Feher didn't have to wait for hours or days for a simulated world to come alive, as you can see. He went further to compare the paper that took 3 weeks to compute and the one he did with Intel's AI, as you can see in the video. Look at the result. The one that took so long to compute didn't only smoothen out the noise, but smoothed out the details too, losing a lot of details in the process. Let's take a look at what Intel's method will do. Now that's so much better. Although it is still not as sharp as the reference simulation, it's a good result. According to Dr. Carole Jolnai-Feher, in some regions, depending on your taste, it might even be more pleasing to the eye than this reference, and it gets better. Intel's technique focuses on the noise and also does the upsampling, which gives it the ability to create a higher resolution image with more pixels than the input footage. Let's take a look at Dr. Carole Jolnai-Feher's last comparison. He started by saying, "I wonder what it will do with this noisy mess. I have no idea what is going on here, and neither does this previous technique." Dr. Carol Jolnai-Feher explained that the previous technique is called the neurobilateral grid learning-based method and was only introduced a few years ago. And now have a look at this. Here, Doctor revealed how long the noise filtering took. He said this all runs not only in real time, but it also runs faster than real time. Yes, that means about 200 frames per second for the new noise filtering step. And remember, the light simulation part typically takes 4 to 12 milliseconds on the scenes. 5 milliseconds later, he got a better result. Wow! Personally, I think Intel's new AI truly has amazing tracing results. What do you think about the video? Tell us what you think in the comment section. Also, you can check out Dr. Carol Jolnai-Feher's channel through the link in the description box. Thanks for watching this video till the end. I hope to see you in the next video. If you haven't liked or subscribed to this channel till now, kindly do so, and don't forget to check out our new videos from time to time. See you later.